So this is a really special type of a quadrilateral. Remember, a quadrilateral is just any shape with 1, 2, 3, 4 sides. And this is a parallelogram. We have the BC and ED are both parallel. They're never going to intersect. And BE and CD are also parallel. They're never going to intersect. So there are two crucial ideas that we can automatically know if we are given one angle in a parallelogram. The first question we're being asked to solve is, what is the measure of angle C over here? And you see here, angle B and C are both up here on the same side. They both are way up there on the top side. They're next to each other. But you can just visually see this angle here is not the same angle as this one. This one is smaller than that one. So they're not going to be the same thing. What we know when two angles are next to each other, or how we'll talk about it, when two angles are adjacent angles, they're going to be supplementary. And that means that this angle plus the angle next to it have to add up to 180. So 60 plus what number equals 180? If we subtract that 60 from 180, we get that our angle C is 120 degrees. So we can automatically get one of our angles. Now, we're being asked to find the measure of angle D. And you see here that angle B and angle D are on opposite sides of the shape. You have to travel across the shape to get to those two angles. And that means we're going to call them opposite angles. And if you look, it looks like those angles are pretty similar, angle B and D. They both kind of come in. And the automatic knowledge we are allowed to know about opposite angles are that they are congruent. So if angle B is 60, angle D is automatically the same thing, 60 degrees. Same thing over here. Angle C is all the way across from angle E. They're on opposite sides. Opposite angles are congruent. So if angle C is 120, angle E is also automatically 120 degrees.
All right, guys, for skill 13, we're going to be jumping into a shape called a parallelogram. And all a parallelogram is if we have two sets of parallel lines. There's that word again, parallel, right? We have parallel lines going this way, parallel lines going this way. We end up with a parallelogram, okay? And that's the name of this shape. And there's some special rules that go along with a parallelogram. The first one being that if we have opposite angles, angles on the opposite sides of our parallelogram, they are congruent, or they're equal to each other. So on this example here, I've got this angle 36, and I've got this angle up here, which has an x in it, but that doesn't really matter, okay? If they're opposite from each other, that means that they're congruent, okay? Which means that 36 equals 10x minus 4. I'm just going to write that as an equation. Opposite angles are congruent, so I can just say that those two things are equal. Okay? And now all I have to do is solve this equation. And we see that x is equal to 4.
Now what we see here is a different type of angle relationship inside of the parallelogram. We see that these angles aren't on opposite sides of each other anymore. They share that one side. They're kind of next to each other. And we have some different knowledge we know if they are next to each other. And adjacent is just a fancy way of saying next to. So if we see adjacent angles, angles that are next to each other, that share a side, then we automatically know those two angles are supplementary, which means they add up to 180. So if we go back here, we see that both of these angles are both over here on this side, so they're next to each other. So we know that they're supplementary. This angle plus this angle, they have to add up and be 180. So I can write an equation, 135 plus my little algebra expression down here, 14x plus 3. Those two angles have to add up and equal 180. Now we just have to solve for x. I'm going to combine my like terms to get 138 plus 14x equals 180. I will subtract 138 from both sides to get 14x is equal to 42. And I'll divide each side by 14. And I'll end up that x is equal 42 divided by 14 will equal 3.
Okay guys, so our next parallelogram looks like this. And all of a sudden we've added these lines that go through our shape. So these lines have a special name, they're called diagonals. Right? It's just a line that goes diagonal across our parallelogram. Okay? And in parallelograms, these diagonals have a special quality about them. And this is true for every type of parallelogram. The diagonals bisect each other. And if you think back to Unit 2 and remember what the word bisect means, bisect just means to cut or to cut in half. And how that's going to help us on this problem is it gives us RF. And RF starts here, goes to the middle, right along that diagonal. Okay? And if that diagonal is cut in half, that means that not only is this part 18, but since it's cut in half, this other part down here is 18 as well. Okay, so when it asks us to find RT, we're going to look over here. RT is the distance from R all the way along our diagonal down to the bottom. Well, that's just the orange line plus the pink line. Okay, and if I add those two things together, it's just 18 plus 18. Okay, our diagonal here is going to be 36. RT is equal to 36. These problems do get a little bit more difficult when we start dealing with algebra and dealing with x's instead of just numbers, but you'll see the shape hasn't changed, okay? And we're still being asked to find RT. This time it gives us RF. So I'm going to do that one in orange again. RF, this line segment right here is 4x plus 1. And this pink segment, FT, is down here below. And this one is 5x minus 4. Okay, so what do I do now? Well, I remember that my diagonals bisect each other, which means that this diagonal here cuts RT exactly in half. Okay, and if it's cut exactly in half, that means that the two halves are the same or congruent. Okay, which means that I can write my equation like so. I know that the orange line segment, 4x plus 1, is going to be equal to the pink line segment, 5x minus 4. And if I've got it set up like this, all I have to do is solve for x. Okay, so I'm going to take away 4x from both sides. I'm going to add 4 to both sides. And I find that x is equal to 5. So I'm done. Except for one thing. I found x, and my problem doesn't say find x. It says find RT. And RT is our diagonal. It starts here at R, and it goes all the way down here to T. Okay, so I haven't found RT yet. What I'm going to have to do is I'm going to have to take x, and I'm going to have to plug it back into one of my equations. So the first equation, the equation in orange, was RF. It's 4 times x plus 1. But I know what x is now. I solved that. Okay, I know that x is equal to 5, so I'm going to replace this with 4 times 5 plus 1. 4 times 5 is 20 plus 1. This is just 21. Okay, so 21 is what RF is actually equal to. Okay, but once again, I have to remember, I'm not done yet. Okay, I know that RF is 21, but it asks me to find RT, and I haven't done that yet. Okay, so I'm going to come back over to my shape. This part here is 21. Okay, and since I know that the diagonals bisect each other, I know that this diagonal is cut exactly in half. If this part's 21, that part has to be 21 as well. So all I have to do to find the length of the whole diagonal is I have to add 21 plus 21. RT is just 42.